My video today is in the area of polar coordinates. Polar coordinates is a system in a plane, starting from O, which is the origin, and R, which is the distance, is the direct distance. And then theta, which is the angle directing the ray to its polar coordinates. To find the area of a polar coordinates, we have to use this formula: 1/2 from the integral from alpha to beta of the function square d theta. My first example is to find one of the petals of the rose curve at r4 cosine 3 theta. To solve this, we will have to use the formula. So we have to use 1/2 then of the function 4 cosine square, because in the formula is square, so we have to square that. And since we know is a cosine of 3, we know it has 3 petals. So if we want to sketch the graph, we know it has to cross the x-axis and then has to have 3 petals. So once that, then we can start solving the function. But we also have to know where it's bounded at, so we can integrate it, because we have to find the intervals. The intervals we already know is from pi over 6 to negative pi over 6. So we know that alpha and beta are pi, the interval is pi over 6 to negative pi over 6. Okay, now we're gonna start solving it. I'll write the function once again. Okay, so we had that the area was from, 1/2 the integral from pi over 6, to negative pi over 6. Then of the function, which was, we said was 4 cosine of 3 theta square d theta. Okay, so simply what we can do is start squaring. We know that this is gonna be 16 cosine squared theta, and then what we can simply do is the 16, move it out to the front, and then 16 divided by 2 is 4. So we can simply already have 4 from the integral of negative pi over 6 to pi over 6. I'll write the intervals in a second, but then it's cosine square theta d theta. Okay, now we know this is an identity, and that identity is 1 plus cosine 2 theta over 2. This cosine square equals that. So we can replace the cosine square theta with that. So we had, it was 4, and now the cosine theta, like I said, we replace it with the 1 plus cosine 2 theta over 2. Oh, and I forgot one thing. The 3, it's in the same place as the 2, so that we change it to a 6. because 3 times 2, like in the formula, that gives us 6. Now we can integrate that from the interval of negative pi over 6 to pi over 6. Now the 2 that we had there, we can simply move that 2 into the front like we did with the 16, and then pi over 6 to negative pi over 6, and then we have 1 plus cosine 2 theta. Now that's more simple to integrate. And once we integrate that, we get 2. The integral 1 is theta, and the integral of cosine 2 theta is cosine. It's sine because it's the antiderivative, so it's sine 2 theta over 2, and then from negative pi over 6 to pi over 6. Okay, so then when we plug in that to the function, we'll get we're gonna get 4 pi over 3, 4 pi over 3, and that's how because we just simply plug in the values for pi over 6, and then we subtract it minus negative pi over 6, and that's how we conclude to 4 pi over 3. That was our first example. Now we're gonna move on to finding the area bounded by 2 curves. This was just one curve. Okay, so our next example is going to be finding the area of R2 cosine theta and R equals 1. So we gotta know how the graphs look. So we can quickly sketch a graph for that, and we know this is gonna be 1, 1, 1. So R1 is just a circle. And then 2 cosine theta we know is also a circle, because we determined that by the coefficient in front of the theta. So that graph is gonna be shifted to 2. So it's going to look like this. So now we have to find the area of that. We know that this right here is R equals 1, and we know right here that this is the graph of R of 2 cosine theta. Now we simply to integrate that, we have to set them equal to each other, and then solve and then find our intervals. So when we set them equal to each other, we get 1 equals cosine theta. To solve for that, we simply divide 2 on each side, and then we have 1/2 equals cosine theta. So when is the cosine equals 1/2? We know that it's at pi over 3 and 5 pi over 3. Okay, so now we can simply integrate that, but we have to determine the intervals. We already have the intervals, but now we know that our intervals always have to be in alpha and beta, and that equals negative pi over 3 to pi over 3. And that's simply because pi over 3 and 5 pi over 3 are in the same range in the unit circle. So if we think about it, in the unit circle, pi over 3, we know that this is 90 and that's 270 and that's 0 and that's 180. So pi over 3, it's right there. And 5 pi over 3 is right here. So we can simply call that negative 5 pi over 3. So we can start integrating now. So we do the same thing with the formula. We square both curves now. Not only one, but we find the, we square both of them. So we write the formula again, 1/2 the integral from pi over 3 to negative pi over 3. And then we have 2 cosine theta square minus 1 square. Okay, so here we know that 2 cosine square is gonna give us 4 cosine square. So that's gonna be 4 cosine square minus 1, because 1 square is the same. So now this turns into 2 cosine 2 theta plus 1, and that's because of our identity, and I'm gonna show that right now. How did we conclude that 4 cosine square minus 1 gives us 2 cosine 2 theta plus 1? That's simply because when we have 2 cosine 2 theta plus 1, we know that this, we simply distribute the 2, and then cosine 2 theta is our identity. So that's gonna be cosine squared theta minus sine squared theta plus 1. So then when we distribute, we have 2 cosine 2 squared theta minus 2 sine squared theta plus 1. Now right here in the sine squared theta, we can change that to 1 minus cosine squared, because we know that sine squared plus cosine squared equals 1. So when we have this sine squared theta, we can just simply rewrite that as 1 minus cosine squared. So we're gonna have 2 cosine 2 theta minus the same thing we distribute, and that's gonna be 1 minus cosine squared theta plus 1. So when we do all of that, it's just simply gonna give us 4 cosine squared theta minus 1. Yeah, minus 1. And that's how we get to that. This goes to that because simply of our identities. So now we can start integrating. And that was just an easy shortcut to do when we have a short minute of time in the AP exam. Okay, so we had that it was 2 cosine 2 theta plus 1. and our integral was from negative pi over 3 to pi over 3. Okay, actually we're gonna do that 0, because since it was two sides, we're gonna multiply that by 2, and we had the 1/2 right there because of our formula, and this is already square because like I showed. So since it's two sides, this and that 2 cancel, we have 1 there, so pi over 3, 0. Now we rewrite cosine 2 theta plus 1, and now we can start integrating. And that's going to give us 2 sine 2 theta over 2 plus theta. Okay, and now that simply it's gonna be from 0 to pi over 3. And now we just basically plug in the values, and then when we do that, let me rewrite it again. So it was 2 sine 2 theta over 2, and that 2 comes from the formula. I don't know if I wrote the 2 before right there in the previous equation, but the 2 goes there. Plus theta from 0 to pi over 3. Now this and that 2 cancels, leaving us with sine 2 theta plus theta. So when we plug all of that, we get radical 3 over 2 plus pi over 3. And that's our answer. And if you guys want me to show you how to get that, I'll show it right now. Sine of 2 pi over 3 is radical 3 over 2. So that's radical 3 over 2, that's how we got there. And now sine of, and then plus pi over 3, we just plug in 0 for, not 0, theta for pi over 3, and that's how we get pi over 3. And now sine of 0, because 2 times 0 is 0, so the 2 we take account of, but it's just that it just equals 0. So sine of 0 is 0. So basically we have radical 3 over 2 plus pi over 3 minus 0, and then 0 we plug in for theta, and then when we just add all of that, we just get radical 3 over 2 plus pi over 3. So that's basically how we get to there. So this is how you find the area of a polar coordinate. And finding that is just like to show us the area that is within the curve. And to conclude all of this, we just have to remember the formulas that we learned, which is 1/2 the integral from alpha to beta, and then of the function, because we have to square the function because it's part of our formula, and that's simply it. And then when we have like a question like this, we just simply have to look where the graph is bounded by, and then that's how we determine our alpha and beta. So that is it, guys. Thank you.